In this video, we'll go through exam questions that cover the criteria, use equally likely outcomes to find the probabilities of simple events and express them as fractions. You can locate the questions on the mathsmaths.com website under level 1. The questions come from different exam boards. We'll start with the non-calculated questions and then we'll move to the calculated questions. Here is the first one. John is a checkout assistant in a supermarket. There are 5 tills and 5 assistants. The supervisor allocates the tills to the assistants randomly at the start of each day. No one likes the till next to the door. What is the probability that John will get the till next to the door today? Give your answer as a fraction in its simplest form. As the assistants are allocated randomly, and there are 5 assistants, so that means the probability of the till next door being allocated to John is 1/5. Because only 1 out of the 5 assistants will be allocated that particular till. This is already in its simplest form, so we won't change it. A fair has a spin the arrow game. A player wins a prize if the arrow lands on a 5. What is the probability of a player winning a prize? Write your answer as a fraction in its simplest form. So a player wins if the arrow lands on a 5. So how many 5s do we have here? There is 1, 2, 3, 4 of them. Out of the total, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 4 12s. We can divide both numbers by 4. So we get 1 and 3. So 1/3 is the simplest form of 4 12s. Now we move into the calculated questions. Oscar is organising a show. Visitors to the show choose their seats at random. There are 350 seats available. These seats are numbered from 1 to 350. Oscar places a prize under each of the seats numbered 17 to 25. What is the probability that the first visitor chooses a seat with a prize? Okay, so seats with numbers 17, 18, 19, 20, 21, 22, 23, 24 and 25 have prizes. So how many of these? So that's 1, 2, 3, 4, 5, 6, 7, 8, 9 out of 350. So the probability that the first visitor chooses a seat with a prize is 9 350ths. Now the question doesn't ask us to simplify, but the fraction is already in its simplest form. So even if the question asked, we wouldn't be able to change this. How can you be sure that that's the case? So 9 can only be divided by 3 or by 9. So dividing 350 by 3 doesn't give us a whole number. Dividing 350 by 9 doesn't give us a whole number again. That's why this is the simplest fraction, the simplest form of the fraction. A group of dancers raised some money for a charity. Here is some information about the money raised. One of the dancers is chosen at random to give the money raised to the charity. What is the probability that this dancer raised less than £10? So we have 2 columns within the table, money raised in pounds and number of dancers. We're looking for amounts that are less than £10. So the first group here, £4.99 or less, that is less than £10. 5 to 9.99, that again is less than £10, but not the other groups. So we have 15 and 23 dancers. So that is 38 dancers out of the total, which is 60. So the probability that the dancer picked raised less than £10 is 38/60. The question isn't asking to simplify the fractions, so I'm just going to write it as it is. John fills a fruit bowl with 6 apples, 4 plums, 5 oranges, and 3 pears. The first customer chooses a piece of fruit at random. What is the probability that they choose a pear? There are 3 pears out of the total number of fruits, which is 6 and 4 and 5 and 3. 6 and 4, that is 10, and the 5 is 15, and the 3 is 18. So 3 18s. Again, question isn't asking us to simplify it, so we're just going to write it as it is. But if you want to simplify, then you'd get 1/6. The class tutor has provided some snakes for the students to handle. 5 of the snakes are green and 4 are brown. Zach is first to choose and picks a snake at random. What is the probability that he picks a brown snake? So 4 of them are brown. Out of the total, which is 4 and 5, that is 9. Reg buys 24 wrappers. 6 of the wrappers are blue. At the party, Reg's son is first to choose a cupcake. He picks one at random. What is the probability that he will pick a cupcake in a blue wrapper? Give your answer as a decimal. So we're looking for blue wrappers, and it's 6 of them, and that is out of 24. So writing this as a decimal, we know that this fraction line here means division. So 6 divided by 24 is 0.25. A group of friends play a game of cards. They have already taken 9 cards from the pack. A player wants to know the probability that the next card is a spade. What is the probability that the next card is a spade? Give your answer as a fraction in its simplest form. So in the table we have 3 columns: card type, number of cards in the pack at the start, and tally of cards taken already. So we have this type, like a black circle. Number of cards in the pack at the start was 2, and 1 of them was already taken, so there is 1 left. And then we have diamond, 4 at the start, 2 already taken, so there are 2 left. And we have the spade, 6 at the start, none taken, so there are 6 left. We have hearts, 6 at the start, 1 taken, so that means 5 left. We have clubs, 4 at the start, 4 taken, so none left. We have star, 2 at the start, 1 taken, so 1 left. We're interested in spades, so that is 6 of them out of the total that is left. So we have 1 and 2 makes 3, and 6 makes 9, and 1 makes 10, and 5, that is 15. So 6 15s. And we need to write this in its simplest form. We can divide both numbers by 3. 6 divided by 3 gives us 2. 15 divided by 3 gives us 5. So 2/5 would be the answer. You visit a restaurant that is holding a raffle with a cash prize. A free ticket is given to each of the 40 people in the restaurant, including you and Josh. You meet Raj and Katrina in the restaurant. They suggest that you and Josh share your raffle tickets with them and share the prize equally if you win. Calculate the probability of winning with Josh and then the probability of winning with Josh, Raj and Katrina. Give your answers as fractions and decimals. Show you're working out and write the answer in the box below. So with Josh, that would be 2 of them. So 2 people out of 40. And that is 1/20, the probability of winning with Josh. The probability of winning with Josh, Raj and Katrina, that would be 4 out of the 40. So that is 1/10. And we need to write these as fractions and as decimals as well. So fractions with Josh 1/20, with Josh, Raj and Katrina 1/10. As decimals, we know that 1/10 is 0.1 and 1/20 is 0.05, but you can always work it out with a calculator. We are moving some swords into a new display. Below are the weights of the swords in kilograms. What is the mean and the range of the weights of the swords? Show you're working out and write the answer in the box below. To work out the mean, we'll add them all together and divide by how many there are. So 1.3 plus 2.1 plus 1.7 plus 2.4 plus 0.9 plus 1.3 plus 1.5 plus 1.9 plus 1.1 plus 1.3 plus 2.1 plus 2.2. So that is 19.8 divided by 1, 2, 3, 4 times 1, 2, 3, which is 12. So that gives us 1.65 as the mean. The range, we work it out by taking away the smallest number from the greatest number. The smallest number is 0.9 and the greatest is 2.4. So 2.4 take away 0.9 gives us 1.5. You pick up one of the swords at random. What is the probability that you pick up a sword that weighs more than 2 kilograms? Give your answer as a fraction in simplest form. So this is more than 2 kilograms. This is more than 2 kilograms. And this one and this one. So it's 4 of them out of the 12. We can simplify this fraction by dividing both numbers by 4, so we get 1/3. Another stall has a wheel on a stand. The wheel is divided into 32 equal sectors. The pointer is spun and has an equal chance of landing on any sector. Each sector is numbered 1 to 32. If the pointer stops on a multiple of 5, you win a prize. What is the probability that you will win a prize with one spin? Give your answer as a fraction in simplest form. Show your working out and write the answer in the box below. So we're looking for multiples of 5. What are multiples of 5? The clue is in the word multiple, multiply. So 5 times 1 gives us 5. 5 is a multiple of 5. 5 times 2 is 10, so 10 is a multiple of 5. 15 is a multiple of 5. 20, 25, 30, 35, 40, and so on. We're only going up to 32, so 30 is more than enough. So we're looking for these numbers: 5, 10, 15, 20, 25, and 30. So that is 1, 2, 3, 4, 5, 6 numbers out of 32 in total. We've got to give our answer in its simplest form. So we can divide both numbers by 2. So that gives us 3/16. And we can't go any further because 16 cannot be divided by 3 to give us an answer as a whole number. So 3/16 is the simplest version of the fraction. Lily puts 3 red balls, 4 blue balls, and 5 green balls in a bag. Lily picks one out without looking. What is the probability that she will pick a green ball? Give your answer as a fraction. Write the answer in the box below. So we're looking for green balls, and there are 5 green balls out of the total, which is 3 and 4, which is 7, 7, and the 5, that is 12. So 5/12 is the answer. A bag contains 6 red balls, 6 yellow balls, and 6 blue balls. Express as a fraction the probability of picking out a blue ball. Show your calculations and the workings out here. Write your answer in the box below. So, blue balls, it's 6 of them out of the total, which is 6 and 6 and 6. So that is 18. Dividing both numbers by 6, we get a third. Also, another way to look at this would have been they have equal probabilities because we've got equal numbers of balls for each colour. So that's why it's a third. A fair, ordinary 6-sided dice is rolled. Write down the probability that it lands on a number greater than 4. Give your answer as a fraction. So it's a 6-sided dice, so you'd have numbers 1, 2, 3, 4, 5, and 6. And we're looking for numbers that are greater than 4. So that is 5 and 6. So 2 numbers out of the total of 6, which is also a third if you want to simplify it. The table shows information about flight delays for 60 flights to Turkey. Estimate the probability that Jack's flight will be delayed by at least 1 hour. Use the data in the table. So we have delay time and number of flights. No delay, less than 1 hour. 1 hour to 3 hours, more than 3 hours. We're looking for delay times that are at least 1 hour, so greater or equal to 1 hour. So that's 1 hour to 3 hours and more than 3 hours. So that's 8 and 3, which is 11, out of the total, which is 60. And that's the end of the questions.